Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing stats and math at University of Toronto. Today we'll be going over some commonly asked math questions at both the high school and college levels. If you need some homework help or tutoring, please check out the link in the description below. Okay, so now let's start our session for today. Alright, just let me zoom in a little bit. Alright, so the first question is asking us to prove that derivative of secant x is equal to secant x tangent x. Okay, so if we want to show that the derivative of secant x is equal to secant x times tangent x, first we need to rewrite. We know that secant x can also be represented by 1 over cosine x, right? And second, we need to apply the quotient rule. Okay, so the derivative of 1 over cosine x is equal to cosine x times derivative of 1 minus 1 times derivative of cosine x over cosine x squared. Okay, so we will have 0 minus negative sine x over cosine x times cosine x, because cosine x times cosine x is just going to be equal to cosine x squared. Alright, so we are left with sine x over cosine x times cosine x. Okay, and because we know that sine x is equal to 1 times sine x, so we use this to substitute the sine x, so the new numerator will be 1 times sine x over cosine x times cosine x, and that will be equal to 1 over cosine x times sine x over cosine x. And now we need to apply another identity, which is tangent x is equal to sine x over cosine x. Secant x is equal to 1 over cosine x. And we can see the tangent x can substitute the second part of the equation, and the secant x can substitute the first part of the equation on the right hand side. Therefore, we will have secant x times tangent x, and that's exactly what we're trying to prove. Okay, so yep, so now we can write our conclusion. Therefore, the derivative of secant x is secant x times tangent x. Okay. Yep. So for this question, we will write the secant x first. So instead of finding the derivative of secant x, we're trying to find the derivative of 1 over cosine x. Okay. And after we write it as 1 over cosine x, we apply the quotient rule. And remember, whenever you're applying the quotient rule, always remember there's a square at the denominator. So don't forget that. And then we simplify the equation. And when we reach this step, we divide, or say we separate sine x to 1 times sine x, which is exactly the same, but it helps us to better convert this into the forms of one function times the other. And then for our last step, we have 1 over cosine x times sine x over cosine x, and we know that sine x over cosine x is equal to tangent x, and then 1 over cosine x is just equal to secant x. So we have our answer, secant x times tangent x. And yeah, so that's what we have for this question. Okay, let's leave a comment. So solution is correct. No doubt. Solution is correct. Just give me a second. Okay. Okay, so our second question today is asking us to find the slope of the tangent line to the curve. Okay, so find the tangent line to the curve y is equal to x over 1 minus x as a point 1 over 2, 1. And we need to find the equation of the tangent line. Okay. All right. So the first thing we need to know is whenever we talk about the slope of the tangent line of any given curve at a given point, it is always the derivative with respect to x. Okay. So yeah, let's write it down here. So slope is always slope of the tangent line given curve at given point. It is always its derivative with respect to x. Okay. Thus, the slope of the tangent line of any given point of y is equal to x over 1 minus x is its derivative should be dy dx is equal to 1 minus x times the derivative of x, which is just 1, minus x times negative 1 over 1 minus x squared. Okay, and by simplifying that, we will have 1 over 1 minus x squared. Okay, so the point 1 over 2, 1. Okay, so at the point which is given by 1 over 2 and 1, the slope of the tangent line is the slope of the tangent line is m is equal to 1 minus 1 over 1 minus 1 over 2, because we just substitute x by 1 over 2. Okay, square, and that will be 1 over 1 over 2 squared, which is equal to 1 over 1 over 4, which is gonna be 4. Okay. Okay, so now we need to using the point slope form. Okay, so using point slope form, okay, which is given by y minus y0 is equal to m times x minus x0. And remember that that is crossing, it's right here, crossing 1 over 2, 1. Okay. So we have y minus 1 is equal to m is equal to 4, which is calculated about 4 times x minus 1 over 2. Okay. So in other words, this 1 over 2 is x0, and 1 will be y0. Okay, and now we just need to leave y on one side and all the other things on the other side. So let's simplify the equation. So we have 4x minus 2, and we have y minus 1 on our left hand side, and now we just need to add 1 on both sides in order to get rid of the extra negative 1. Okay, so y minus 1 plus 1 is equal to 4x minus 2 plus 1, which is equal to y is equal to 4x minus 1. Okay. Yep. So that would be the equation of the tangent of the given curve passing through 1 over 2, 1. Okay. Yep. So let's say that's the first part of the question and second part of the question. So here, after solving m, we will know the slope, and then here we will know the point slope form. Okay. Yep. So let's leave a comment. Yeah. Yeah, and the graph should be something look like this. Let's leave a comment. Solution is correct. Okay. So our next question is asking us, how do you find X-intercept, and Y-intercept of a graph of an equation? Okay. So let's first talk about the X-intercept. So X-intercepts are found by keeping y is equal to 0 and so for x. Okay, so remain y is equal to 0 and so for x. Okay, so let's say we have a line, that is something look like this. So y is equal to x minus 1. Okay, and if we want to find the x-intercept, which is right here, we need to remain y is equal to 0. So in our case, that will be 0 is equal to x minus 1. And then we plus 1 on both sides, which will give us 0 plus 1 is equal to x minus 1 plus 1, which is x is equal to y. And now we have our coordinate, y coordinate, which is 0, and we have our x coordinate, which is 1. So we have the x-intercept 1, 0. So x-intercept, yeah, so x-intercept 1, 0. Okay, and if we are looking for the y-intercept, we need to remain x is equal to 0, and so for y. So for y. Okay, so yeah, in this case, yeah, so let's use the same graph. Great. So here will be the y-intercept. So now we need to remain x is equal to 0. So we have, first let's copy down the function. So y is equal to x minus 1. and we need to remain x is equal to 0. So we have y is equal to 0 minus 1, which gonna give us y is equal to negative 1. All right. So we will have the y-intercept, which is 0, negative 1. Okay. Yeah, so that's basically how we find the x-intercept and the y-intercept. Oh, and just one more thing. If you come across a parabola, which is something look like this, just keep in mind sometimes it will have more than one x-intercept. So in this case, here will be a x1 and here will be a x2. Okay, yeah, so just keep in mind there are probably more than one x-intercept in some graph. Okay, so let's leave a comment. So solution is correct. Well done. Oops. Okay. All right. So next question is asking us, what is the formula for the surface area of a box? Okay. So first let's draw a box. So should be something look like this. Okay, so here we have a box, and as you can see here, it is formed with 6 rectangular faces, and the top and bottom faces are having the same area, and 2 of the side faces have the same area, and the front and the back surface have the same area. And now let's just call this box with a length L and a width W and a height H. Okay, and let's write the keyword down. So 6 rectangular faces. Okay. So if we want to talk about the front and back surface area, that will be L times H, right? And since there are 2 of them, so that's going to be 2 times L times H. Okay, and the side surface area will be this part, right? So that's gonna be H times W, and since there are 2 of them, so that's gonna be 2 times H times W. And lastly, we have the top and bottom. will be this part. So that's the top and the bottom. Okay. So that is going to be L times W, and since there are two of them, so it's going to be 2 times L times W. And then, yeah, so the last step will be just add them up. Okay, so surface area will be equal to 2LH plus 2HW plus 2LW. Okay, and yeah, so that's how we find the surface area of a box. Surface area of a box. Okay, so let's leave a comment. Solution is correct. Well done. Oh, and just one more thing. You can also take the 2 out and then put all the other things in a bracket. Yeah, so exactly the same thing. Alright, so I think that's all we have for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit your own questions, please read the link in the description. Remember to leave a like and a comment and share this video with your friend. This has been Andrew from OneClass. I hope to see you soon. Bye.